we are at the grand finale, so to speak, of PO55. We've talked about what it means to solve a quadratic formula. It means to find the x-intercepts. And then we talked about what type of parabola would have two solutions. It crosses the x-axis twice. What type of parabola would have one solution? Its vertex is on the x-axis. It only crosses it once. What type of parabola has no solutions? It does not cross the x-axis at all. Okay. Then we talked about how there are three forms of a quadratic equation because there are different ways you can write the terms ax squared, bx, and c. For ax squared plus c, you should have these already filled out. Our method, the order of operations, and our hint is our solutions will always be opposites. Last week, we closed with ax squared plus bx. We can't use opposite operations here because it has those two x terms. So our method is factoring out the greatest common factor. You should have these three examples filled out here. And our hint is that one of our solutions will be 0. That's the freebie, okay? The third type, the grand finale, is if you have all three terms, ax squared plus bx plus c. Now, the good news is, if you remember PO51 and you remember PO52, you've already done factoring, which is the method that you need to use for this. Why are PO51 and PO52 power objectives? Because if you don't understand them, you've just made PO55 a lot harder for yourself. If you do understand them, PO55 just became a lot easier, okay? Because we're building on things we've done in the past. So for all three terms, ax squared plus bx plus c, our method is factoring. There really is no hint here. But you will either get 0, 1, or 2 x-intercepts. Okay? Let's look at some examples here. Y equals x squared plus 9x plus 20. First of all, what does it mean to solve for or to solve a quadratic equation? Find the x-intercepts. What do we know that y equals? 0. Okay? So first, we're going to rewrite this to be 0 equals x squared plus 9x plus 20 because we're setting y equal to 0. We are looking for the x value or values that makes this equation 0. Those are our x-intercepts. Leah. Sorry? Please. We're not going to do that here. If we were doing opposite operations, we would want to move our constant over. But because we can't do opposite operations because we have these two x terms here, our method's factoring. And if you remember the factoring method, we're looking for that number puzzle, right? Two numbers that multiply to make 20, two numbers that add to be 9. Exactly what you did in PO51.
Oh, I get it.
Okay?
This is so easy.
What's the solution to this number puzzle? Nathan?
5 and 4.
5 and 4.
You're so smart.
Okay? 5 times 4 is 20. 5 plus 4 is 9. We know that our factored answer is going to be 2 sets of parentheses. They're both going to start with an x. Folks, they both start the same. They both start with an x. One of them gets a plus 5.
What?
The other one gets a plus 4.
Oh, yeah.
Okay? Now in PO51, this is where we stopped. So in PO51, our objective was simply to factor them. Okay? Now in 55, we actually have to go and solve the equation for x. But remember, we want this equation to equal 0. We have two expressions that are being multiplied together. What value for x makes x plus 5 equal 0? Negative 5. Negative 5 plus 5 equals 0. And remember, if we can set this equal to 0, even though negative 5 plus 4 is a negative 1, 0 times negative 1 is still 0. So this kind of goes back to our last example, where we set each expression equal to 0, right? What value for x makes it 0? What value for x makes x plus 4 equal to 0? Negative 4. If we plug in negative 4 for x, we get 0. It doesn't matter that negative 4 plus 5 is positive 1. 0 times 1 is still 0. So where does this parabola cross the x-axis? It crosses at negative 5 and negative 4.
Whoa.
3, 2, 1. You are quiet. Nathan.
Do you start to do the greatest common factor thing though?
If your what? Okay. If your equation has a coefficient to your x squared term, then you have to factor out the greatest common factor, like PO52. But if it doesn't, if it's just x squared, PO51, we go straight to that number puzzle. We get our solutions, and there you have it. Okay, Chase. That's our answer. X equals -5 and x equals -4. Eli.
Should we write in parentheses as like a point on?
Don't write it in. No, you don't have to write it as a point. Because they're two separate points, right? -5, 0, -4, 0. Okay. And if you were to check this, remember, with any equation, you can check it. If we took -5 and we plugged it into our equation, so it's -5 squared plus 9 times -5 plus 20. -5 squared is 25. 9 times -5 is a -45. And 25 minus 45 is a -20. -20 plus 20 equals 0. It works. If you plug in -4 for x, it will also equal 0. Okay, so just like any other equation, when you solve for x, plug it in, make sure the equation works, which we can see it does. Okay. Next one, x squared minus 3x minus 40. There is no coefficient to x squared, so we can go straight to our number puzzle after remembering we are setting this equal to 0 here. So what are two numbers that multiply to make -40? And those same two numbers adding to be -3. Sorry, what? 8 and -5 will be +3.
It's -8 and 5.
-8 and +5 will give us -3. You were close. Yep. So setting up our solutions, our two sets of parentheses, we have x minus 8 and x plus 5. What value for x makes x minus 8 equal to 0? 8 does. So one x-intercept is 8. What value for x makes x plus 5 equal to 0? -5. So this parabola will cross the x-axis at 8 and -5. Right? The last one, we go back to PO52. Okay? PO52, we've got some more stuff to do here. Yeah.
So it should be -8 and oh wait, never mind.
Yeah, you're looking to make it 0, right? What value for x makes this 0? If we plug in 8 for x, 8 minus 8 equals 0, it doesn't matter that this is 13 here. 0 times 13 is still 0. You plug in -5 here, -5 plus 5 is 0. Doesn't matter that this is -13 over here. -13 times 0 is still 0.
I already finished.
Okay? What do we have to do in PO52 here, that coefficient, that x squared term? What's the extra steps involved here, Will? Okay, is there a greatest common factor between 6, 11, and 10? No. So thankfully, we don't have to actually do it because we can't. There isn't one. Okay? So what do we do now? How do we get this number puzzle all set up here, Sam? Good. Start by multiplying your a and c together, which is 6 times -10, and that's -60. And we need that -60 because that is what our numbers need to multiply to equal in our number puzzle. Okay? What two numbers multiply to make -60? And those same two numbers add to be our middle term, +11.
Sam has it.
Okay? And again, start with those factors of 60, right? There's only a certain number of factors of 60. It's got to be one of those. Maddie.
Can I say it?
Sure.
4 and 15. So.
4 and 15 would give us +19 if we added them.
Sorry. Negative. It's yeah.
What? 15 and negative 4, right? It's not negative 15 and positive 4, because that's negative 11. We need positive 15, negative 4. Okay? Positive 15, negative 4. Now, remember, the other key to this here, when we set up our parentheses, what are we starting them with?
6x.
6x. Right? Not just x, 6x. That coefficient to our x term kind of changes everything here.
I messed it up again.
Yeah,
I got like no space.
I was worried when you said that you were all ready to
Yeah,
finish.
like.
It's different than the two that we had previously. Now one gets a positive 15 and one gets a negative 4. Those number puzzle solutions come into play here.
Oh, no.
Okay?
200 set of parentheses will like read them.
Hold up. You're like 3 people talking at once. Sam. Yes. Because we cheated by putting a 6x into each of them, we now have to undo that by fixing it and simplify. Okay? So we can divide 6 and 15 by 3. We can divide 6 and negative 4 by 2. How can we be confident that this is all fitting together here?
Oh, I see.
Not grandpa yet. We're not quite there yet. That's to check our final answer. Caitlin?
The two numbers that you divide by and multiply to equal a certain number.
The two numbers that we divided by, multiply to equal that extra 6 that we put in there. We put an extra 6 in. We have to take a 6 out somehow, and we do that with that simplifying. So now we've got 0 equals 2x plus 5 and 3x minus 2. Okay. Now just for space issues, I'm going to rewrite that up here. We've got 0 equals what? I don't want that. Go away. There we go. 2x plus 5 and 3x plus 2 minus 2. Okay. Now just like before, we want these to equal 0, right? We're solving for x. In PO52, we were done here. This was it. We factored it. But now we're solving for x. So we want to make each set of parentheses equal to 0. And this is where that negative b over a trick becomes super handy. Because if we remember negative b over a, the opposite of our constants divided by our coefficients, x equals negative 5 halves.
Oh, I see.
Okay?
Oh.
If you solve it using opposite operations, you see that you subtract 5 from both sides
This is magic.
and divide by 2, you get x equals negative 5 halves anyway. Okay? Essentially, to solve a two-step equation, the solution is the opposite of your constant divided by the coefficient, because those are the two steps that you do to solve a two-step equation. You move your constant over using opposite operations, and then you divide by whatever the coefficient is. Okay? So, what would our second x-intercept be here from 3x minus 2? Nick? Positive 2/3. The opposite of your constant, the opposite of a negative 2 is a positive 2. Paul, divided by our coefficients, 3. Okay? If you solve that mathematically using our two-step equation process, you'd start by adding 2 to both sides, divide both sides by 3, and you can see x equals 2/3.
Whoa.
Okay? Now these solutions can be checked as well, just as the other ones. If you want to plug in 2/3 into this original equation in your calculator, you're going to put 6 and then 2/3 in parentheses, square it, take 11, 2/3 minus 10. You put that into your calculator exactly as it's written there, and it will equal 0. Okay? It is not that hard to check these answers here. Really, if you understand how to put it into your calculator. You're replacing x with 2/3, and you can do the same thing with -5 halves. 6 times -5 halves squared plus 11 times -5 halves minus 10. That will equal 0 as well. Tristan.
So you're gonna make us do the entire equation of it.
We'll see.
Yes.
Okay. Questions on these? It's PO51 with one extra step. Solve for x. It's PO52 with one extra step. Solve for x. Okay? That's what this full quadratic equation method is to solve for the x-intercepts. Right? Your homework for tomorrow is to finish PO55 part 2.
Yay.
Okay?
Wait, there's more? Sure, come on.
There are a couple of them worth talking about.
Oh my god.
There are a couple of them worth talking about.
It's not even that
But I'll only talk about them if you give me time.
Which one was the last one? You want to show us which one was the
You're
last
finishing PO55 part 2. Whatever's not done.
one? Yeah, I know, but what one's it?
I'm waiting for people to be quiet, Cole. I'd love to talk about some of them. Right now, people are just making noises and complaining. Yes, Chase. Yes. So for this middle one here, x times x minus 13 equals 30. Again, we can't factor it until it's written as a quadratic equation in standard form. So to get that quadratic equation here, we're going to distribute the 13 or the x in. X times x is x squared. X times -13 is a -13x, and that equals 30. Okay, all we've done is we've simplified that left side by distributing that x into the parentheses. Are we ready to factor it now? No.
Not just yet.
What do we need to do next, Paul? Or Sam?
Oh shoot, that's a 13x. I'm not sure.
Okay.
Yep, never mind.
Caitlin?
You move the 30 over.
Right. It has to equal 0 first.
Oh.
So we're going to move our 30 over using opposite operation. It's positive 30 on the right. It'll be negative 30 on the left. And now we can dive into factoring it.
Caitlin's a smarty pants.
Okay? It has to equal 0 first because that 0 represents y. And if we're looking for the x-intercept, y has to be 0. This bottom left one here, kind of a similar thing, right? It's not written as a quadratic equation, so if we distribute this 4x into the parentheses, 4x times x is 4x squared, 4x times 4 is 16x, and then we have plus 15 equals 0. Are we ready to factor?
Yes.
Yes, we are. Okay. These other two here,
We got it.
you just have to make it equal 0. Move this negative 20 over using opposite operations. 30x squared plus 25x minus 20 equals 0. The last one. We have to move that 22x over, but where does it go?
It goes right after the 56.
Right. Standard form, it goes between our x squared term and our constant. Again, using opposite operations, 56x squared minus 22x plus 2 equals 0. You go to work. Okay? So these equations have to equal 0. If they're not, put them that way, right? Do the math to make them. Or if it's not written as a quadratic equation, you might have to do some simplifying first. This top right one, another example that negative 5x is brought over. It's put between our x squared term and our constants. And opposite operations will make it positive 5x, right? So it's really only 12 questions you need to do, 11, because we already did that the x squared equals -9 question. But the first two go back to ax squared plus c, opposite operations. Then you skip a row, because we did that one. The top row on this page is ax squared plus bx. You've done that one, right? Factor out the greatest common factor. Then you got these factoring questions here. Okay? So really only 12 to do, 11 if you were taking notes that day that we covered that one. Yeah?
Did we do these things?
We did the first one. Okay, so that's part of the 12. All right?
On PO55.
Pay attention, yeah, PO55 part 2. I'm going to erase this ink here, so if you need it, hopefully you have it, otherwise watch the video. But on PO55 part 2, we did this top row for homework. We did this x squared equals -9 as part of class. So you've got these two to do. We did the next row for homework that was due today. So you've got the entire back page. The first row is ax squared plus bx. That's the GCF method. And then you've got factoring to finish it up. So it's not that bad. Hopefully. If you've been doing your homework up until now, not that bad. Okay? But do tomorrow. And then I'll wrap up PO55. Questions, comments, concerns, complaints, compliments, congratulations, or
Is there only one more?
all right, homework due tomorrow. That's it, math.
Don't forget to like and subscribe.